Welcome back to the channel. In this particular video, we are going to look at how to solve a linear programming problem, not necessarily to solve, but how to write it in standard form, right? So let's just get right into the video. So you have this optimization problem. So you're going to optimize Z, right? We're going to optimize this. We're subject to the constraints. So here are the constraints. Now, we know that we are going to need a couple of things. We're going to need some slack variables, right? So, we're going to need one slack variable here, S1. We're going to need another slack variable here, S2. We're going to need another one, S3 here, right? So these are the slack variables that we will need to solve this problem. Now, something else that we need is we need to focus a little bit on the variables, right? Here, the condition on X1, X2, and X3. So one thing that we know for LLP in standard form is we need all the variables to be greater than or equal to 0. So all the variables to be greater than or equal to 0. This is how we write LPP in standard form, right? So as you can see, not all of them are of that nature. So you can see X1 is of the right standard, so X1 is good, but X2 is not good. We have greater than or equal to 1, so this is not good, and X3 also is not good, right? So because of this, we need to rewrite those in a way that will be very suitable for a standard LPP. Okay, so now let's look at X2. So what happens is we have this condition for X2. Now think about it. So now we need to introduce another variable to help us write X2 in a way that would befit this greater than or equal to 0. Okay, so let's see what we can do. So basically we can write X2 as what? 1 plus another variable. So let's call it X2 prime. Okay, so in this case, it means that what? So it means that basically we have X2 as what? 1 plus X2 prime. So I think this is clear, right? Where of course, X2 prime will be greater than or equal to 0, right? So instead of working with X2, now we can just work with what? X2 prime, right? So wherever we see X2, we change it to what? 1 plus X2 prime. So that would make it easier. Now, which other variable is also problematic? X3. So right now we have X3 to be unrestricted. So X3 could be positive or could be negative, right? Now think about it. Now we need to write X3 as in such a way that we are going to use. So we need to write X3 in terms of 2 or more variables, such a way that these new variables will be greater than or equal to 0. Now a natural way to pick this is to pick 2 numbers, right? Difference of 2 positive non-negative numbers, right? So this is a natural way to pick this, and I'll explain why. Now, if these 2 numbers are non-negative, so think about it. If I have difference of 2 numbers, right, what will happen? So either this is greater than this, and if that is the case, what will happen? X3 will be positive. So X3 will be greater than or equal to 0 if X3 plus is greater than what? Or equal to X3 minus. But X3 will be less than or equal to 0, so it will satisfy the other side, which is the negative side, if the reverse is the case, if the first number is less than the second number, right? Now think of it as if let's say X3 is positive, right? Let's say it's 9. So what happens is you can have this as what? 6. Think about it as 6 minus 3. This will this will become around 12 minus 3, right? 2 positive numbers where the first one is bigger than the second one. But let's say X3 is negative, let's say minus 9. What will happen is this number will now become minus 12 plus 3, right? Where, as you can see, X2, or basically, let's think about it this way. Let's say X3 is negative. What happens? Let's say X3 is minus 9. So what happens is you can kind of have so 3 minus 12, right? It will be the reverse, right? Where X3 will be smaller than X3 plus will be smaller than what? X3 minus, right? So that is a way to think about this. So we can do this, right? So this is another way to represent x3, and this representation satisfies the condition that we want. Well, what is the condition? X3 could be positive or could be negative, and this would satisfy difference of two non-negative real numbers, basically. Okay, now that we have this, now that we have representation, so what we need to do next is to substitute these values into this and then add in our slack variables. So let's do that. Let's go to the first one. So the first one, the optimization Z equal to 2x1 plus, now your x2 is now 1 plus x2 prime, right? Then minus x3, what is your x3? Your x3 is now what? x3 plus minus x3 minus. So this will now give you 2x1 plus x2 prime minus x3 plus x3 minus plus 1. So this is the first one. Now let's move to the second one, the conditions now. So for the conditions or constraints, what do we have? For the first one, so we have 2x1, okay, that's fine. Remember that x1 is greater than or equal to 0, so this is fine, okay? Plus x2, which is 1 plus x2 prime, and minus x3, which is the same thing, minus. Now, because we're having less than or equal to, so we have one slack variable here, plus s1, this will be equal to 5. So this is what we have. So now we can solve this now, simply put, we can have this way, plus s1 will be equal to 4. Okay. So this is what we have for the first condition. Now, the second condition, so this is for the first, so this is the second one, right? So let's have, so let's look at the third one. So the third one is what? Minus 3x1 minus 3x1 plus 2x2. So minus 3x1 plus 2x2. So that's 1 plus x2 prime. What else? Plus 3x3. Plus 3x3, remember, is this. And this is equal to what I believe is greater than or equal to minus 3. So we have one slack variable on the other side. So that is minus s2 is equal to minus 3. Okay. Now notice that we are having minus x2 here because of the sign greater than or equal to minus 3. So when you change it to equality sign, so that will be minus 3 plus something s2. So when we move the s2 to this side, that is how you have minus s2 here. So if you're wondering why this is not plus s2, is because the slack variable is on the other side of the equality because we have greater than or equal to. So if I put in equality, that means this, what we have on the left-hand side is greater than minus 3. So the extra value would be kept as s2, which will be the slack variable on the right-hand side. Now, when you move the s2 to the left-hand side, you have it as minus s2. Okay, so now we can just expand this now. So 2 times 1 is 2, 2 times x2 prime, you have 2x2 prime, plus 3x3 plus minus 3x3 minus, then minus s2 equal to minus 3. Now we can just move this number to the other side. So that will give us minus 3x1 plus 2x2 plus 3x3 minus s2 equal to what? Minus 5. Now, we can generally just multiply the whole thing by minus so that we keep this, this constant positive. So that will give us 3x1 minus 2x2 minus 3x3 plus 3x3 minus plus s2 equal to 5. So good. So this will be the next equation that we have. Right? So this will be the third one. Okay. Now let's move to the fourth one. So what's the fourth one? The fourth one says what? x1 minus 3x2 plus 4x3 greater or equal to 2. So we have x1 minus 3x2. So minus 3, again, 1 plus x2 prime. Then we have the next one, plus 4x3. Plus 4x3 is this. Greater than or equal to 2. So we are going to have minus s3 again equal to 2. Okay. Now we need to solve this again. We have x1 minus 3 minus 3x2 prime plus 4 x3 plus minus 4 x3 minus s3 equal to 2. So what does this give us? This gives us x1 minus 3x2 prime plus 4x3 plus minus 4x3 minus s3 equal to 5. So we'll take the minus 3 to the other side. So, and this gives us the next equation. Now, what is remaining is the last one, x1 plus x2 plus x3 equal to 4. So x1 plus x2 plus x3 equal to 4. And this is what? X1 plus 1 plus x2 prime plus x3 prime minus x3 plus minus x3 minus equal to 4, because this is equality. So what do you have? X1 plus x2 prime equal to 3, right? So this will be the last one. And now what will be the last condition? Remember that x1 is greater than or equal to 0, and every other thing is greater than x2 plus is greater than or equal to 0, and x3 plus and x3 minus are all greater than or equal to 0. Now this is the standard. So basically optimize this first one, which is here, subject to these constraints. This one, the second one, the third one, the fourth one, the fifth one, and then the final, the condition on the non-negativity of the variables. All right, so that solves this problem. So I hope you find this interesting. Make sure that if you enjoyed this video, you like the video, and then subscribe to the channel and share this among your groups, whatever, to your friends, so that they can benefit from this channel as well. I will see you guys in the next video.